Proposed two technologies, both on biodegradable materials. So one is on the biodegradable abrasives that is to be used on materials, I mean like metals or even walls. These are the materials we know conventionally it is not biodegradable, and it is environmentally harmful. So he has developed a material which is based on polylactic acid. Okay, instead of the kraft paper. He has achieved a GSM of 8.5 to 9 GSM coating over the surface, and he has developed the papers from ultra fine to fine range of abrasives. You know the sandpapers, right? So that is what we have developed it, right? So it could be used in automobiles, electronics, and many others. The product is patented, and it can be even scaled up also for commercialized for higher volumes also for industrial output. So the process is very simple comparatively, and in fact the process employs very less energy intensive compared to the conventional thing, and it could be potentially be employed even for small scale industries with a minimal setup. So this is the block diagram, and as you can see, the heating process is actually eliminated in this process, wherein he is actually coating it at a room temperature, right? So the process is drastically reduced. The cost is also reduced. Of course, polylactic acid is a little bit pricey, but keeping the environmental conscious in mind, this product is developed. Right. So who are the potential collaborators who could work for is both the industries as well as some academia who wanted to develop further on this technology, right? So what he has achieved remarkable is the coating with the room temperature. So that process is actually patented, which is actually being employed to the next technology also, which is used in terms for food packaging, right? I mean, the process is similar, but two products. We are coming up with the two products, right? So, can I go to the next presentation? Yeah. Okay. Okay. You can ask the questions. Yeah. Right. Right. No, the kraft paper is also biodegradable. Yeah, and yes, yes. Yeah, and also the grains, right? That is also biodegradable. That is a what to say? The crystallized form of polylactic acid.
Okay, fine.
Yes.
And what is the normal thing used otherwise?
Some aluminum oxide.
Aluminum oxide.
Yes. Yes. Yes, sir. Glass transition temperature. I mean, that is where the technology is protected, right? So we are not using the technology of 90 degrees Celsius. We haven't taking the product to 90 degrees Celsius. We are processing it at a room temperature.
How is the bonding done?
Through spray on the paper.
Adhesive is what? Same as earlier or different?
That's a little secretive, sir.
But it is new.
Yeah, that's a new. Yes, exactly. Yes, that is also biodegradable, sir. Yes, that's patented. Yes. Yeah.
What are the applications like in automotive engineering you said?
Yes, sir. You can for the surface treatment of the components, automobile components. Conventionally, sandpaper is being used, right, sir?
Okay.
So instead of that, we could use this thing. And the next technology can. The same. The next one, the biodegradable. Yeah. So, I mean, the process is relatively similar to the previous technology also. Here, the application is for the food applications. And you can actually replace the aluminum foils instead of the conventional. Means we can replace aluminum foils with the coated polylactic acid. Here, the polylactic acid is, I mean, made as a composite along with the peanut shell waste. So it is mixed with a particular ratio and then coated onto the, made it as a film. So this is what the results were. So it is completely biodegradable and it is also, microbial resistant. It offers good microbial resistance compared to the conventional. Conventionally, plastic is used in case of a microbial resistance, but again it is, environmentally not good. So here this is biodegradable as well as microbial resistance. So this composite of polylactic acid and peanut shell waste, peanut shell carbon. PSC is actually peanut shell carbon. So we mix it at a particular ratio, and then you can actually coat it onto the films. I mean, you can actually cast it as a film, and then you can start using it as a product. So the making of peanut shell carbon is presented here, which is where pyrolysis is used. Right. So this is about the technology. Here food packaging industries can actually start exploring this technology instead of the cling wrap. I believe the cling wrap is actually banned for its use. I'm really not sure, but some aluminum foils are being used, and we have actually tested for the. I haven't included the laboratory validation parameters, everything, but the strength, tensile strength, and all the other parameters are comparatively good for this product. Yeah.
This is going to replace the aluminum foil or the cling film?
Both.
They both have different purpose, different applications.
No, yeah, my cling film is not for I don't think it is microbial resistant.
Cling is, it blocks the oxygen or blocks any.
Yes.
It doesn't do that. So is it stretchable, this one?
No. I mean, little bit stretchable. Yes, a little bit stretchable. Yes. I mean, of course, you don't have that. You can't really stretch like the plastics, but still, it has a reasonable properties compared to the plastics. Yes. That's it. Sir, I really don't understand Hindi, sir. Sorry. Yes. No, it is very flimsy, sir. I don't think that would be the suitable application for this. You are trying to use it like a banana leaf or a food plate, correct? No, I don't think that would be suitable. No, it can't be. When you try to harden the material, then the cost will be too high. Yes, sir. In case if you want, we can send the samples to the companies. Yes. In fact, we have it. We have much sufficient samples there in our laboratory. We could send it immediately. Not here. I'm representing. Yeah, not here, sir. Sorry. Yes.
Materials. Is that 23395? T95? T95 has two.
Yes. Yes, correct. No, the 5% we are adding actually, it doesn't really change the colors. No, that's what, it doesn't really change the color contrastingly. Yes, you can't really notice the black color in it. Yes, exactly, sir. The carbon is used as an antimicrobial agent. In fact, PLA itself is an antimicrobial agent, but still it lacks some strength because PLA is as such, it is a rigid material. So when we add a peanut shell carbon to it, it actually improves the properties. That could be used potentially for food applications. Yeah. Huh? Yeah, we have tried it in the coconut, you could see. All right. See, the coconut, I know the fungal growth is actually reduced while using the film. In the below in the second slide, the coconut, the fungal thing is actually reduced. Yeah, microbial protection is enhanced by using the film, and also for the fungal growth in the bread slice, you could see it. No, instead of the typical 5-day shelf life, you could increase it for 7 days. No, it is just now we have finished it. As soon as we start transferring the technology. Yes, we are exploring for startups also, but no, our university doesn't have startup policy yet, sir. So otherwise, this could have come up. Yes. Sure. Anything else? Yes, sir. See, cost-wise, it is everything, anything biodegradable. Cost-wise, it is expensive, sir. At least 2 times. Right. So even the conventionally, right now we are using we started using biodegradable carry bags, which is again expensive. Normal plastics ones. Yeah, normal plastic ones. Because polylactic acid is not being manufactured in India, I guess, sufficiently. So we are actually importing the material, polylactic acid from nature. If you that's what, sir. Any biodegradable plastic bags is costlier. Now, biodegradable plastic bags started being used in the market now because of the government's imposition on the plastic ban and everything. So only when the government intervenes, as per the policy intervention, these products could pick up in the market. Of course, it is environmentally beneficial and it has good properties, other properties as well. But cost-wise, of course, we have to negotiate on that.
Like what is the yield? How much, like this peanut shell you have to use to extract maybe a gram of PS?
5 grams. 5 grams.
5 grams out of what?
I think you mean 5%, I can say. 5%. I mean, it is a rough estimate only. I mean,
So out of 1 kg of
yeah, 1 kg of PLA, maybe 5% of it.
I'm asking, you are extracting this from the peanut shells, no? So how many peanuts you are extracting this?
Adding. Yeah.
Yeah, this PSB is obtained from peanut shells.
No. Carbon,
Carbon is
peanut shell,
extracted, no?
carbon, yes.
You extract it from the
Peanut
from
shells,
So
yes.
how much quantity gives you?
I mean,
like
we thought it is a waste, so we didn't really calculate that cost. So, but yeah, I mean,
sometimes it is too
voluminous.
yeah,
You mean to say yes, voluminous. It is there,
the yield
but
is very little. So it is with respect to the scalability, because industry
yes,
is concerned
the
about
first challenge what I could see as a if at all I'm an entrepreneur, the pyrolysis plant, which is a 900 degrees Celsius, but of course it could we could have a miniature pyrolysis plant as well. That is also feasible. Technically, it is feasible. So whatever you say about the volume, I mean, it really doesn't matter. It all depends on the capacity of the industry that is going to take it. Yes.
Okay, any more questions from audience?
I think if you have one sheet which shows comparison between the products that are available in the market, like I can see 3. One is aluminum foil is there, cling film is there, and also paper is there.
Yeah, correct. Burger peppers. Yeah, burger peppers, correct. Yeah.
So how do you compare? Butter paper also environmentally.
That's right. That's what I meant, burger
How do
peppers.
you compare this with that in terms of the advantages and the cost?
Cost, of course, it is high, sir. But in terms of advantage, it is environmentally beneficial. But in terms of ease of handling, of course, the butter papers is taking the lead. But it is too harmful, I can say, because of the what is that? What do you say? The coating on it is actually adding microplastics to the environment, which is too dangerous. I mean, you can even use normal paper, but those papers which has microplastics, it adds more danger to the environment. Yeah.
Thank you.
Thank you.